Hello and welcome back to Workshop Wednesdays. I am here at TVL Group in sunny Brentwood. Today we're looking at the way we stow our trucks. In particular today we're looking at 3D printing with Aaron. Looks really cool, so let's go in and let's take a look. Okay, Aaron. So what are we doing here? So you're going to 3D scan our tools, yeah?
Yep, so we're 3D scanning your tools today to be able to create jigs and fixtures to be able to locate them into your fire engine easier.
Yep, fantastic.
So we're using a 3D scanner and we're scanning the actual tools to be able to pick up the geometries of it.
Oh, brilliant, okay. So how does that work? How does the actual scanner work?
So the scanner basically sends out like a pattern and it measures how quickly it returns.
Oh, right, okay.
And then it picks up the different contours and geometry of the actual part.
Brilliant, and then builds a picture on this just here.
Yep.
So with that picture, obviously that's an awesome picture. That is really high detail as well, isn't it? It's very impressive.
So it's really easy to do. You can just follow the path round of the actual tool and we'll be able to create a full image of the actual.
These dots here, I guess they're for reference, are they, for the
Yeah, so it's allowing the scanner to actually register where it's positioned.
Right, okay.
And just work all the way around, and then we'll be able to mesh the actual parts together, which will then allow us to actually have a full 3D model of the tool, so everything will fit exactly perfectly. It saves a lot of time in terms of prototyping.
Yeah, the benefit for us as a fire service and our engineering department is the fact that we don't have to manipulate so many small things. Potentially we could build prototypes quite easily and quite quickly.
Yep.
And have them slot in and out instead of like having to manually fix and move these every time we want to change our stowage. We could literally scan something, get you guys to build something and then ship it out, and that's excellent for us because it's great value for money, less time the engineers have to build things, and the downtime of the trucks as well will be brought down. Absolutely,
yep.
Yeah. This is an example of one of your 3D printers.
Yep.
Can you tell me about what kind of materials you use?
So this is our Mark Forged, and it uses a material called Onyx.
Okay.
Which is it's nylon based.
Yeah.
And it can also come in fire retardant material.
Brilliant. That suits us.
Yep. So it's got two nozzles on the actual extruder of the printer, and we can inlay carbon fibre into the actual parts.
Is that for strengthening, I guess?
Yes. So it makes the parts extremely strong.
Yeah.
And also the detail on the actual parts is really detailed.
Yeah, that is really detailed. I'm actually very surprised at how the level of detail that goes into. I imagine it doesn't just come out like this. You've got to finish it, I suppose.
Yeah. So this had a little bit of support material on, but it literally just peels off really easily. And then the parts are functional and ready to go straight away pretty much.
Yeah, very impressive. Cool, thank you very much, Aaron. So we are back a few moments later. We are at Fleet Workshops and we are back with the prototypes of the awesome 3D printing that Aaron and Terry and the team down at TVL have produced for us. So, we popped back a few weeks later down to TVL with an appliance. Obviously got the new layout straight into the truck. Instantly it looked great, exceeded my expectations. The tools landed exactly where they should have. Really straightforward, really high quality 3D printing that they've done, and this is a good example of that. So these, this one here is for the cutters. So I'll tell you a little bit about the actual piece of stowage itself. So this 3D printed item, it obviously made of plastic. The plastic is of a grade that is highly heat resistant for obvious reasons, water resistant and oil resistant as well. It's strong enough that it withstands knocks and dropping of equipment onto the plastic, but it's also soft enough not to wear or break the equipment itself. So this will always break before this piece of equipment does. Obviously, these pieces of equipment are way more valuable than the stowage is, and this is the piece of kit that we need to make sure is safe and works every time when we turn up to an incident. So the grade of material used here is really important, and they have made sure that the grade that they've used is just what we need, which is brilliant. Obviously, these will most likely break, crack in time, but the beauty of using plastic as a material is that we can plastic weld, which basically means melting plastic together. And there's a really innovative way of plastic welding that TVL Group has introduced me to. They've got some cylindrical small parts of plastic that will fit to a well-known spinny device that's about that big. Now that device spins up, the contact between the plastic creates the friction creates the heat melts the plastic into position where we need to. And that was a great thing, great example of seeing other experts in their field use new ways of thinking, new ideas, new tools. And that is a really highly efficient way of fixing these. So that's really good. Now this tray would be made of aluminium. These plastic 3D printed parts will be have an interference fit. And what I mean by an interference fit is that they'll use aluminium bungs. They'll most likely pre-print the holes in the plastic. These aluminium bungs, I imagine they'll freeze them like via nitrogen, etc. Freezing of aluminium means it will shrink, fit into the holes, and then as the aluminium warms up, it expands. So as it expands, it will be in place and it'll expand into the holes that it needs to, creating a really tight interference fit, which will most likely you can only really remove again by either breaking the plastic or by cooling down the aluminium bungs or studs, whatever you like to call them. So yeah, that's really straightforward, really good. These all can be pre-made, which is really, really good for us because it's more efficient use of our time. We don't have to spend time building the trays. The trays can be made because they can scan each individual appliance and make a tray to fit that appliance, whether it be for RTC equipment or we look at other equipment that we'd like to stow, we change our stowage on. But RTC is where we're here right now. As you can see, they fit really well because they're custom made. And because they're custom made, there's less likely a chance to damage the goods, the tool, should I say. And it's less likely that the firefighters would experience trouble returning the tools to where they should be. So these are easy for us to stow, efficient for us for reduced labour times, really good for the tools. This would probably have a strap over here so it would hold it down nice and snugly. And then also, massive thing about the 3D scanning, which is an area I'm really interested in, is that you can build a space in real time. So this is scanned, goes straight over to the computer, and then if you individually scan items as well, you can manipulate them within that 3D world in an instant. So why is that good? Because at the moment, if we, for example, wanted to move this from a vertical plane to the horizontal, as I said, this is heavy. We'd physically have to get 2 engineers to hold this horizontally, okay? And then the 3rd engineer would have to trace and create the design whilst the engineers hold that in place. And that's obviously not going to be comfortable and it will take a long time. And then each time that we want to build a bracket, etc., we'd have to go away, spend hours building that, put it back, get everybody to hold that in place again, trial and error. Obviously it takes a lot of time. In the 3D world, these can be created and then all the maths, all the sizing, etc., is in the computer already. So it knows how big this needs to be. It knows that it will fit in this space here. It knows that if it went from one plane to the other, it will fit. It can happen. Obviously, this is heavy. There's an engineering that would have to be involved around designing a horizontal bracket, etc., etc. But it's just an example of how much quicker and efficient the 3D modelling is. And it's something that here at Essex Fire, and personally myself, would like to invest more time into because obviously the fire service as a whole, our fantastic team in technical services, along with all the firefighters and operational people that are involved in it. We're always looking at new technologies, always looking at ways to bring better value to our service, always looking at ways to bring better techniques and better equipment to help provide a better service for our communities. So that means that we do change equipment, we do bring in new equipment, and because of that, the space on the truck is at a premium. Although you might look at a truck and think, wow, that's huge, there's loads of space, there is a lot of equipment on there. And there's a lot of space that's required to keep that equipment. And we really need to look at new ways of how to stow it. And the 3D modelling, the 3D printing is a great example of how to do that, because we can literally scan, say, like a locker that's got, for example, like where our hose reels are, etc. The scan will bring up all the space, can give us the dimensions, and then we can literally pick up items of equipment and put those into that space without physically going to the truck, without physically having to get on a stool or get up a ladder and lift it, or get several engineers involved to do that. We can do it all on a computer screen in front of us, and that saves so much time. And just the efficiency of that, being able to see instantly if it fits, if it doesn't fit, is a game changer, and really something that I'm very keen to be a part of. So I'm really grateful for the team down at TVL for us to get involved with the techniques that they use and to experience their techniques, experience their expertise in this field, and really integrate that with us with some of those things at Essex Fire. So it's efficient, doesn't damage the tools, and it's better ergonomically in health and safety for our firefighters. And it's brilliant. I mean, once these are made, and they're made like prefabricated, it means that it will make it much faster for us for stow vehicles as well. So when it comes to if we had to change the equipment from that locker to a different locker, we'd literally scan it, build it in a 3D environment, have someone build the trays for us. We go in, screw it down, there's 4 plugs in, and that's really straightforward, it's really quick, cuts our labour time down, cuts the time that we need to keep our crews from changing over. When I mean changing over is that if we have to bring them in, we'd have to give them a spare appliance. The less downtime there is between that, it makes things more efficient. The less downtime full stop means we can do it faster. We can get things changed faster, more efficiently across the fleet, because there's roughly 66 frontline appliances, and you appreciate we haven't got spares for every single one of them. We've got a limited amount of spares that we need to maintain the fleet, which is fine, works really well. But doing things like this just speeds it up, makes it more efficient for us. So, I'm Steve, this has been Workshop Wednesday. I will catch you next month. Thanks for dropping by, and take care.